it rotates. And all the information we had designed originally the spacecraft for big ponds on the surface of really fine-grained material. You know, we're talking about less than an inch size material, because our science showed us that there should be a lot of it. We got there, we screamed because there were boulders 11 stories high. And it wasn't quite what we expected.
And you can't fit a boulder 11 stories high into your canister.
Well, we can't. It's not that big.
Well, bigger boat.
A bigger boat.
And, you know, the problem is when you fly down to the surface of the asteroid, you may not come back out the same way either. So there's challenges with the navigation that you have to think about. And to get to your questions and your comments here, we had designed the touch and go sample acquisition mechanism to basically just touch the surface, as Neil said, and we fire some nitrogen gas, and it basically fluidizes or moves the gravel up, and then it gets collected into this little sort of reverse Hoover or vacuum head, and then we would pull back. The autonomous spacecraft pulls back from the surface. But what happened was we went in 48 centimeters, length of an arm almost, down into the surface of the asteroid, which wasn't, went right through it. Boink, which we did not really expect. Some folks on the mission will say, well, we had some models that showed it could be, but yeah, okay, it could be. But that was a good thing, actually, because it taught us that gravity itself is basically what's holding the asteroid together. Tensile forces between particles is not really doing it very well. Hey, Neil, see, I learned some physics over the last 20 years. And,
yeah.
And the other thing is we're penetrating deeper into the surface. So the surface of the asteroid is being cooked a lot, depending on how much the surface is moving based on the rotation and landslides and impacts. So we're getting down to the stuff that might be fresher. Quote, fresher.
So that's better for you.
Correct. Absolutely correct.
Wow.
The problem was, and you did ask another question there when I get to that. The problem was that when we pulled back up, and did the first test to see what kind of sample we got, we literally moved that 3-meter arm backwards to a camera to take pictures. And I can remember about 4:00 in the morning, waking up and downloading from our mainframe the images and start looking at it. It had all these little spots all over the place. I'm thinking, what the heck are these spots? Long story short, as the world knows, several stones got caught, keeping the flap open. And that we were losing sample every time we articulated the arm.
Wow.
There's another PhD thesis. There's another PhD thesis. Come on.
That's tough.
Yeah, it was right.
That's tough.
So, yeah, that was so the PI had to make some quick decisions with the associate administrator of NASA and other people to basically stow the sample much quicker than we had expected to prevent more from